Good afternoon. Well, it's afternoon here when I'm recording this anyway. And welcome to the first of my Build a CBUS module videos. Hopefully the first of many. So today I'm going to build a CANMIO module. I did actually do a little presentation at one of the Merg East Midlands area group meetings recently, where I demonstrated Build a CANMIO in an hour. In fact, it took quite a lot less than an hour. And I did record that, but the recording quality wasn't great just trying to set it up at the meeting. So I thought I'd set up something properly and repeat the exercise here, perhaps covering a little bit more detail. So the CANMIO is a module I designed some years ago, and it's available from the Merg kit locker for CBUS, MIO standing for multiple input output, and there's a CBUS module that you can do lots of IO with. And you can buy that from the Merg kit locker, and it comes in the all version with everything populated, so you can do all the different types of IO with it, and perhaps I'll do another video on setting it up and using it. So this is the printed circuit board that you get, and I'll look at that in more detail in a minute. And if you buy it as a Merg kit, you'll get all the components nicely laid out on component cards and a set of building instructions with it. If you're buying CBUS kits, perhaps modules that are not available from the Merg kit locker from RME, they'll come like this. There's just bags of components, and where available, you can download the build instructions from the Merg knowledge base. And of course, the CANMIO build instructions are indeed available there if you don't have the set that came with your purchased kit anymore. So tools I'll be using, I've got my trusty old Weller soldering iron, probably some 45 years old now, bought when I was at college, and temperature controlled, which is always a good thing. This older type soldering iron, the temperature control is via a thermocouple in the tip there. This has had new thermocouple, new heating element and so on over the years. You can still buy all the bits for these old Weller TCPs, and the temperature is defined by the tip you put on it, and you can buy the tips with a thermocouple in it. More modern soldering irons are going to have a dial where you can actually set the temperature. And my trusty Merg bendy jig, which is used for, as you'll see in a minute, for bending the resistors and other components to the right spacing to fit into the circuit board. Combined with, hopefully I don't need it, but just in case I do, solder sucker. This particular one is one that Torben recommended, and it is very good, better than most. And standard wire cutters and so on for trimming the back of the circuit board as we'll go along. So we'll have a closer look now at the actual CANMIO PCB, and there it is. Quite a lot on it, fairly compact. What I try and do with all the circuits I design is that wherever there's space, I put the component value. As you can see, the resistors there have actually got the values. They'll be hidden once it's assembled, but they're an aid for assembly. So you don't necessarily have to look at the component parts list or the circuit diagram every time you're putting a component in. You can pick out the right component and the value that's written on it most of the time. The Merg instructions will give a particular order, suggested order for assembly, and that's based on height. I will use a completely different order because this is a video not of how you should do it, but of how I do it. And you can then make your own decisions as to the best way that works for you, because I'm using another tool I'm using here. This came from Rapid Electronics many years ago. Unfortunately, they don't sell this particular one now, but it's a little PCB stand, and you'll see that in action. And that allows me to have the PCB supported, and therefore the way I do it, it no longer matters the relative heights of the components as you progress through. So the order in which I do it is one which I've found works for me. If you're doing it flat on the work surface, then it's much easier if you start with the lowest components and work up in height, so that when you put the board upside down, the latest component you put in is just nicely held in place. Okay, so we'll get started. Now, first thing I do, because I know these boards quite well, and I'm doing it from just a bag of bits, is I'm just going to pour all the bits out onto my work surface and pick them up as I go. You may well wish to cross-check all your components against parts list and schematic, make sure you've got all the right parts and that you know which is which. But I'm just going to have a big pile of components and just work from them. There we go. So what I do before I start using them on the support, PCB support, is I will do the resistors and diodes, which are all very low profile, flat on the PCB. I'll do those first. And so the first thing I do is take my bendy jig and I just take all the resistors. And I happen to know, because I designed the board, that all the resistors are at the same spacing, which on your bendy jig, it's that position there on the second spacing up from the thin end, and use the one towards the top end to drop the resistor in. And then I just fold the ends over and hey presto, that's bent to the right thing. So all I'm going to do, without really any concern at this stage on value and so on, I'm just going to do all of those so they're ready for use. All the resistors, dig them out of the package here. I'm sort of using the methods that over the years I've found give me the fastest build. And as you become more familiar, you know, the first time you build a particular module, it'll take you longer. Second time you build a module, probably be half the time. And by the time you build a few, you'll be down to a fraction of the time of the first one you built. I have the rubbish bin conveniently to my side here, so I can just throw things straight in as I go. And that I think is all the resistors. There's then a couple of diodes in the CANMIO. They're both the same as it happens. And their spacing, as it happens, is slightly closer. So I'll be doing those on the narrowest one at the end of the bendy jig, like that. And now they're all folded, ready for action. So what I'm going to do now is just insert all those into the correct positions in the PCB. You find that when you build a few, if you assemble a number of components and then solder them all in one hit, it is quicker. Now, I'm going on the fact that I know the color codes for resistors and the values are printed on the circuit board, as you can see there. This one, which is brown, grey, red, is 1, 8 and 2 zeros. It's a 1K8. If you don't know the resistor color codes, you can Google resistor color code charts. You can download a chart and very easily find the values from that. And if you're working from your component card, of course, you'll have all the values on that. So I'm going to pop these into the circuit board now. And although it doesn't matter from an electrical point of view which way round they go, I like to line them all up so the color codes read left to right, so I can see them at a glance and just so it looks prettier. But it won't stop it working if you don't fit them all the same way around. And of course, I've built enough of these that I tend to know where the components are without having to look too far. And that just comes with familiarity with a particular module if you're building a number of them. You know, these ones here are more accurate 1% resistors. They're used to generate the correct voltages out of the voltage regulator. So they've got more stripes on them. So orange is 3,3. Then two blacks is 0 and no more zeros, I think. So that makes that a 330 ohm resistor. The red stripe means the 1%. So I look for my 330R on the PCB and there it is up there. So we'll pop that one in. I've got two more of these more accurate versions. That's a 2K2 in there. So that's all the resistors actually in the board. And I'll do the diodes at the same time. They're both over the left-hand side. You'll see there's a little arrow on the board that indicates the polarity of the diode, and the the stripe on the diode there is in the direction the arrow points. So you can see there's a little bar to the right of the arrow, and there's actually a stripe on the circuit board symbol as well. And so that just drops nicely into the holes there. And that one's going to need just a little pull from the other side with a pair of small pliers. It's a slightly tighter fit. But perhaps the distance when I folded it on the bendy jig didn't quite do it. And you'll see with the legs of the resistors, it now sits, the board will sit quite nicely just at an angle like that. That's why I'm around finding my tools out of the video. Right, so I can now just give a gentle little pull on the other side. Now just pop down nicely. Like that. And now, with a little bit of care, in fact, a trick here is to take another PCB you might, empty PCB you might have lying around, and just put it on the top. So you can now turn it over and then slide that out of the way. And now that lot is ready for soldering. So I'm using leaded solder here. As a hobbyist, I'm allowed to. And my technique for soldering with components, it's 4 steps really. It's bring the soldering iron to the joint, so it's touching both the pad and the wire. Solder in is number 2. Solder out and pause is number 3 to let the solder run. Soldering iron away is number 4. I did that wrong, didn't I? Let's do that again. This I can easily rotate round, so I've got convenient access to get to the various legs I want to solder. And so it's a 1, 2, 3, 4. Soldering iron on, touching both the pad and the wire is number 1. Solder in, melted. Pause for a moment is number 3. And take the soldering iron away is number 4. Doing that more quickly, it's 1, 2, 3, 4. And 1, 2, 3, 4. And I'm just going to solder up the rest of those wires now to do all the resistors. What's those 2 diodes? And I'm just gently swinging this round so to give me access in amongst all the other wires to the ones that I want to solder. And of course, just visually inspecting all the time as we go along to make sure we don't miss any. And there's another one down there that needs doing. There we go. And then we'll take little side cutters. I'm using these ones, but there's lots of variations out there. And you're not looking to cut this totally flush to the board. You want to leave the little sort of volcano-shaped bit on there. Now, there are those, and I'm sure they're right, who will say, actually, you should trim to length and then solder. I just find that too difficult, and my defense is that my stuff usually works. But I realise that doing it this way, you don't have solder over the end of the wire. But as I say, I've found that generally my stuff works. So after 40 plus years of doing it, I'm not going to be able to change now. And I've just, whilst cutting, spotted another one that I missed just there. So I'm just going to solder that one up. Now looking at it, if there are any where I feel that maybe I've cut it a little bit low, I can just add a bit more solder there and make sure that the joint looks nice. And you make sure that nothing's shooting across as it shouldn't, and I've got one there that looks like it might be, so I'm just going to trim that back a bit more and visual effect to make sure touching. Now, if you see that the solder sort of bobbles like that one has, it probably hasn't flowed properly, so just a little bit more heat to make sure that looks nice. And I'm just going to resolder these diodes as being fatter wires. They've and making sure that solder has flowed properly. Okay, so that's all the resistors and diodes soldering onto the board. So next I'm going to move to using my PCB support here. Put all my cut pieces. You could probably cut those straight into the bin actually. Just doing a quick visual inspection on the top. So now what I'm going to do here, the way this works is it's got a little sprung bit at one end. So I can pop the PCB in so it's supported from both ends. Release the tighten up one end here. So that's now held. Release the spring. Now that PCB is held, but is free to rotate so I can get to both sides. And I find for me, that works very well. It's very much a personal thing. What works for you? So now the decision is, what do we put on next? Well, I tend to put the pin headers on next because I find that I want to be able to get my hand in around them to hold them in place as I'm soldering them. And it's a pain to do that once you've got other components in. If you're doing the versus the instructions and doing it flat down, you wouldn't do those next because they're a bit higher. So we get a number of pin headers supplied, which we need to cut to the right length. So I'm going to start with the programming header, which is right at the back here, which is a 6-pin. So let us cut that off to be a 6-pin length. And then with the pliers, I'll just pull out one pin, which is and that's the key pin. On the circuit board, we'll see that there's 3 pins and 2 pins with a gap in the middle, so that just drops in. And the technique I use here is that with a finger holding it in place by one pin, I solder a different pin so I don't burn my finger and just tuck it in place. So what I can do now, it may not be perfectly vertical and perfectly in, but with my fingernail on the plastic part, I can just reflow the solder and the pressure of my finger will just reposition it perfectly. Vertically like that and nice and horizontally. Once I'm happy with the alignment, I can solder the other pins now comfortably without disturbing the one that's already been soldered. And so I'm going to repeat that with all the other little headers on here. We may do a little bit of time lapse when I edit this video, just so it's not too painful watching me do this, because we've got 8 servo headers here, each with 3 pins. And so one needs to think of which order to do them in. If I put it in this way, I can get my finger in the front quite comfortably. Going for the back for my finger is more awkward. And so if I started this end, when I come to do the second one, I'd have to do it from the back. So I'm going to do it from this end. And it's worth thinking about which way you're going to do things for ease of holding and getting your hands. So one finger on, solder not the pin I'm holding. Finger now goes in behind, holding the plastic. Bit of solder, straightens up. visually check it's all looking nice. Go back underneath and solder the remaining pins. Just going to chop actually the other 7 of these off of here. Right, we're going to come down to the bottom left here where there's 2 jumper links. One is to link for depending on which can chip you're using. CANMIO allows 2 different of the current can chips to be used by fitting or not fitting the jumper, and that turned out to be a blessing during the chip shortages after COVID, because there was a time when we could get one kind and we couldn't get the other, and because the CANMIO had the jumper link we could use either. Okay, and there's another 3-pin jumper link, so I'm now on to my next set here. So we'll just cut 3 pins off that one. Into the other jumper link down here is next to the other one. Solder that the same way. Maybe I should have done those the other way around, but I can just about get my fingernail onto it, so it's see how that. So yeah, it's gone quite nicely. First. So we have just here a little 3-pin link, which is used to set the output voltage of the second regulator. So I shall cut off 3 pins off my strip. Put one in, trying not to drop it on the floor as I do so. Same technique, of course. Hold pin. Don't solder the pin you're holding, or it'll feel hot. Finger on the plastic. Reflow, get it sitting nicely. Quick visual check. And we'll solder the other 2 pins. So we're getting there with the jumper links. Now, there's actually a little jumper link here. Now this one is, what this jumper link does is it means that the 12-volt supply coming into the main CBUS connector is also jumpered across to supply the I/O. And 99% of the time when you're using a CANMIO, and maybe not as much as 99, maybe 90% of the time, you're probably going to use the same supply for everything. The exception is perhaps you might want to run a separate supply around the layout for servos to ease the load on your main CBUS supply and isolate the 2 for interference purposes, in which case the connector here takes the separate supply, and you might want your I/O to run at a different voltage, in which case you'd feed that in through here. Now, generally, I think the build instructions will say fit one or the other, the connector or the jumper link. You can fit both, but you've got to be careful that if you're feeding a supply in there that you do take the link out. I'm going to fit both to show that you can do it. It is slightly a tight squeeze, but it can be done. Now I have standard 2-pin jumper link here. That's going to go into the 2-pin, which is quite tight up against the diode, but that's okay. And that'll just, because it's a tight fit, it'll just sit there quite happily. So we can solder those 2 pins in the usual way. Now what we need to do, because the connector is going to be quite tight up against it, is we now need to just carefully remove plastic shroud around those 2 pins. Now that they're soldered in, it's quite safe to do so. So here's an old screwdriver which will do the job nicely. So I'm just going to ease that off. And having done that, I can just ease the 2 pins just over this way a little bit, away from the connector. And that will still take a jumper link. That probably looks a lot worse than it is over the way the camera is showing it. That looks better. You can see there that the two pins there, just ever so slightly leaning away from the connector. And that allows, I'm just going to make them both the same. The USB microscope is making that look extreme because of the parallax effect, I think, but that's fine. And now when I come to fit that 2-pin connector, I'm using the 3.5 pitch. The board does allow you to fit a bigger 5mm pitch there, in which case you don't have the option of fitting the jumper link at the same time. Now, one thing that if you're building from the lowest up, you might do as your first thing, and I haven't done yet, is there's a little jumper link, just a wire link because it's permanent, to go in here, LK3, as you can see on the board there. And that's a jumper link that if you're building the board as standard for 5-volt supply, you always fit that jumper link. It is possible to build a CANMIO as a 3.3-volt module, which is very useful if you're interfacing to 3.3-volt circuitry. So I'm just here going to take my pair of pliers because the bendy dig doesn't go small enough for that, and I'm just bending that link around the pair of pliers and pop that in here. If you're driving servos like I probably with this one, you want 5-volt circuitry, so you won't be building the module as a 3.3. But for example, RC522 readers are 3.0-volt. Other modern circuitry may well be 3.3 volt. So you do have the option of fitting an additional little regulator there to power the CAN at 5 and making your main regulator 3.3 volts. It's a useful facility that the CANMIO has, although most probably don't use it. I'm just going to put a little bit more solder on that. It's probably absolutely fine, but it hasn't actually flowed to the other side of the board. So just being a bit picky. And now it has, you can see that links nicely across both. So what's left now is that there are 2 links here. One's a double pin and one's a double 3-pin and one's a single 3-pin. These are setting the double 3-pin sets the IO power, and the single 3-pin is for the pull up or pull down on the output. So I'm going to fit that first. It'll be easier to get my finger in. So we'll take off another 3 pins, pop those in there, in the IO power, and by normal technique, finger on the pin, so on the other end, finger on the plastic reflow, get it sitting nice and straight. Just up. Finally, I haven't missed any as far as jumper links are concerned. The little double one, a link will go on one of those 3 pairs to control whether the IO is 12 volts off the CBUS, 5 volts off the onboard 5 volts, or the output of the second regulator, which gives you some isolation from the first one. And for servos, you generally set the second regulator to be 5 volts and set this jumper link to run from that regulator. Second attempt, hold it with my finger. So I use the same technique on the double one. So what's the corner there? Just have a double check that that's the finger actually. Not perfectly because the side's just slightly high. So I'm just going to reflow that with my finger on the other side, get that up a little bit. That's looking better. That's sitting down nice and flat now. Sometimes you just have to pedal them ever so slightly. I'm using a sponge to clean the head. Some people use the sort of metal strips. I like the sponge because I'm so used to it going, I don't think it's cleaned it unless it's made that noise. You can hear me doing it probably between pretty much every usage of the iron before it goes back in the stand. Right, now we just fit whatever components I feel like fitting next. Often I go for the LEDs because they can be a little bit fiddly. So the red one, which is I'm using for power. Of course, you can fit whatever color LEDs you like for whatever. The convention for CBUS is you have green for indicating slim mode and yellow for indicating flim mode. And as we'd already used those colors, we went for red for power. I'm not keen on the blue and white ones for power because they're just so bright in your face. They tend to be much brighter. Now on the CANMIO, we've got a plus sign, which should generally be visible, and a flat on the other side of the indication of the LED here, which you can see flat on that side, a little plus sign down that side. So your long leg goes to the plus side and your short leg to the flat. And with these, I just hold the top of it with my finger, solder one leg, and then, generally speaking, if I need to reflow it just to get it to go straight, I can do. Generally, with only one leg soldered, you've got a little bit of movement there to get it, make sure it's straight enough. For me, it doesn't have to be absolutely perfect. There are better uses for my time than spending extra time to get the perfect verticals on the every LED. As long as they're straight enough and will do their job nicely, I'm happy. So likewise, where it can be seen clearly. There we go, the angle of the light so you can actually see. Slim LED there, green, flim there. And what I do to make it easier to know the colours, rather than just calling them LD1, LD2 and LD3, you might just move that slightly because it's blocked by the, there we go. Now get the angle so you can read it. It's LD1R for red. And then we've got LD2. You can read it on here. Again, it's the reflect. I can see it by the naked eye better than you can probably see it on the camera. But there we go. You can just about see there's an LD2Y and an LD3G. So those are the suggested recommended colours for reminders, so you get them the right way around. So you can actually fit what you like. So my green LED, long lead going to the positive. Straighten that up. And I solder the second leg. The yellow one, and generally I tend to only cut the wires off the back because it's quicker and more efficient to do them all in one go. When it gets so crowded that I can't solder anymore, then it's time to trim the wires. So that goes positive to the plus again. I haven't got that green one perfectly vertical, but I'm not quite really too sleep over that. I think we'll just tweak the yellow one slightly. If that will exactly match the not quite verticalness of the green one with the yellow one, I think, and then it looks like I intended to do it that way. Yeah. Joint, one of those joints in the previous LED I'm not totally happy with, so I'll just reflow that one. There we go. Okay, that's all the LEDs in. Now, my next move will probably put the IC sockets in because they're fairly low down, and you need to be able to get the soldering iron around them and the fingers on them to put them in. So I'm going to start with the 8-pin one over at the side here for the CAN chip. Now note that that goes the other way round. On most CBUS modules, this is the case with the little byte is shown out of the socket there. And so your matching little byte out of the physical socket goes the same way. And that's to do with the way the pins of the CAN are actually on that side of the chip, so it just makes the circuit board easier and possibly less prone to interference, where your CAN signals just come straight out onto the connector. And that's why you'll find most CBUS boards tend to have that chip the other way up. There we go. So what I do is I just tap each corner, put some pressure on the plastic from the other side, reflow. Sometimes you feel a little tick as it settles down when you do that, although if you've got it right, that's fine. Quick lock on top, it's sitting flat, it's sitting straight, and now I can solder the rest of the pins of that particular device. Angling it so the camera can see it slightly better, which actually isn't quite the natural angle for me to solder it at the easiest, but it's doable. And then, having soldered the other pins, you just double check those two you tacked. Do they need resoldering, or are they actually okay as they are? Here we go. So the next IC socket is the big 21 pin beast. This one has its bite at the top to match on the circuit board, and then it just drops in nicely. Same thing, hold it roughly in place, just tack the two corners. Then with some pressure from below, reflow them. Some people don't like the reflowing bit, but it works for me. Means I don't have to mess around bending the pins over and things. So that's straight enough for me. I'm happy with that. And it's sitting nice and flat on the board. So we can slip the rest of those pins up. On the earth pins, which you can see by the little joining pieces on the edge there that's joining it to the ground plane, you may need to hold the iron a fraction longer for it to flow, because of course you've got the whole of the ground plane acting as a heat sink away from your solder, taking the heat away from your soldering iron. So if you find that when you're going on the earth pins of a device, you might just need to hold it on there for a second longer to make sure you've got the heat and the solder has flowed properly. It looks, the camera's making it look blacker than it does to the naked eye, actually, but that's you'll find that cleans up nicely afterwards and flashes your soldering after you clean it afterwards. The blackness is just a bit of the way that the flux that's come out of the solder is echoing to reflecting to the camera, I think. And then there's one more IC socket to go in. This is fitted either with a resistor pack, which is kind of the default if you're just driving servos or doing inputs. You can also put a driver chip in here if you're driving outputs at a different voltage than the PIC, which is from the IO volts, or you need a bit more current than the PIC can supply. But as soon as you fit the driver chip, that can only be, all of these 8 can only be outputs. So there's our socket. The same technique, pop it in, sits nicely next to the PIC. Tap its two corners. Stick down quite nicely. Need to remove that. All right, so where do we go now? I'm going to pop in the little 100 nanofarad decoupling capacitors. So these are these little chappies with 104 written on them. Now, generally speaking, there wasn't room on the circuit board to actually put the value on all of these, but the general rule is if they're a little capacitor and it doesn't have a value marked on the board, then they are the 100 nanofarad decouplers, which you can cross-check with your parts list and schematic if you wish. One in, and again, these I just finger solder one leg and then solder the other leg. Generally, general rule is that you'll have one of these by each chip, as that provides decoupling to remove noise from the power supply at each chip. That's the idea of them, is that any noise gets shorted through the capacitor. There's one up here next to the pick. And that's all those little decoupling capacitors. Now, the area down here is a little tight, so you do really need to do those in the right order, so that you can still get in. I tend to do the crystal first, which if you're doing that in order of height, you'd be doing fairly early anyway. You check it's got 16 written on the top, which you may or may not be able to see in the camera. And I just pop that in. There are 3 holes there, which sometimes it's a query. The board is laid out so you could fit a resonator or a crystal. Generally speaking, these days a crystal is preferred. The resonator would have 3 legs. Now the crystal only has 2, so you only need to solder the outer 2 pins of that. There are then 2 diddy little capacitors, marked 180. In this case, they're 18. You may find that you get 22s, which is equally fine. So I'm just going to go right in next to the crystal there, because they are the capacitors that the crystal needs to work. 2 right next to each other there. Second one here goes in next to its companion. Is where you need a soldering iron with a reasonably fine tip on it. This isn't a mega fine, it's not as you'll use for surface mount, but it's a lot finer than some of the soldering iron signs you see out and about. Okay, so that's got those in. We've then got a 10 microfarad capacitor, which is labelled, surprisingly enough, 10. I found it. 10. These are tantalum capacitors. They are polarized. You must put them the right way around. You'll get a little bit of smoke if you turn it on and you put them in the wrong way around. You can see one leg's longer. And on the circuit board, you can see that one end of the component label there has got sort of angled end, and there's a positive sign there to confirm that. That's the positive side. And you'll also see the capacitor symbol. The negative side is the white side of the picture of the capacitor, which you can't see that once you've fitted it, but it is a fitting aid. So you've got multiple things to tell you. And on the capacitor itself, one leg will be longer than the other. and generally there's a little plus sign on there to tell you which to confirm that's the positive side. So we'll pop that in and that is just about labelled on the board, although it's quite strong text. You might need magnification. Small text, you might need magnification to see it. So just using my normal technique of just holding it with a finger on the end and then just soldering the two legs. That's good. Happy with that. And then next to it, we've got a 4.7, which is again part of the noise suppression decoupling. On a bigger capacitor value will catch different frequencies. And likewise, the orientation is worked out the same way. I get in there. So now it's important to put this little resistor pack in before you fit this, otherwise it's going to be quite fiddly to get between them. Now on the little resistor pack, it's a 5-way, so 4-way 10k with 5 pins, one's common. So these have 5 pins, and one pin is, they're 4 resistors with it all commoned up to one pin, and you can just about see there, I think, is that there's a little dot on one end, and you do have to put it the right way around. And on the circuit board, you'll see there's a square pin, and also there's a little line that marks that as the common. And so you need to make sure the dot goes that end. And then it's holding it with a finger. We'll solder the two ends. Just check it's sitting nicely. It's pretty good. You can just tweak its verticalness, which is more for aesthetics than practicality. And solder the other pins. So that brings us down to this connector here. This is for daughter boards. The CANMIO has a range of different daughter boards you can plug in to give additional functionality, which I shall cover in other videos. Perhaps have a little mentioning of this one. And there's the connector. And you can see it's got a cutout. And that cutout is clearly marked on the circuit board, so you can put it in the right way around. So, and you do it very much the same way as you would do an IC. Hold it by the plastic, not the metal, so you don't burn your fingers. And I'm going to tack the two corners. Then I can just hold it from the other side, reflow them. If it wasn't sitting down flat, that'll cause it to do so. And then we just do a vertical check. That's sitting nicely that way. And I'm also going to look from the side. And we'll also look at it vertically. Now, it isn't quite perfect, but actually that's near enough within tolerances as to being lined up for the daughter board to comfortably plug into that. I might just be fussy and just tweak it ever so slightly because it's not quite perfectly parallel with the edge of the board. And it just offends my eye if it isn't. So I'll just reflow the joint at one end, tweak it ever so slightly, and funnily enough, that now looks perfect to the naked eye. And in the camera, it looks maybe less perfect. So the camera is, they say cameras never lie, but there you go. But that's now in position where I'm going to be happy with it. So I'm just going to solder the other pins now, as is my normal. I'm going to do the ones this side first because they're a little bit tighter to get the soldering iron in. So really the rest you can do in almost just whatever the components come to hand, really. So here's the little slim switch, little push button. I just ease the pins ever so slightly together with my thumbs, just so it drops in nicely. It can be slightly fiddly to get both. There we are. That's dropped in now, I think. Yeah, and then you just push it in, make sure it's sitting nice and horizontal. And it can then be soldered. They're big pins that take a bit more solder, so heat it up for a moment longer and then run a longer amount of solder in. So you've got plenty on there, and again, hold the soldering iron on for a moment or two first. And then the solder should run easily and run a bit more in because they're big fat pins. We'll need a bit more solder just to comfortably solder that. Okay, let's see what comes to hand next. So I'm going to fit the 4-way CBUS connector next. So that just goes down on here. Like most of the multi-pin things, I'll hold it with my finger and just solder one pin. And I can just push it, and I can see from where it overhangs the side of the board a little bit if I've got it reasonably straight. It'll work if it isn't perfect. We want to look nice, don't we? So that's not looking too bad there. It's comfortable to solder the other pins. That's the earth pin. These need a little bit more solder than the smaller components because they are bigger pins. Needs a little bit more solder to go through. There we go. Now I'm just going to jiggle that position there so that I can get the 2-pin in, the 2-pin connector, which you don't have to fit if you're going to use the this only with the 12-volt supply and not feed in another supply. You could actually fit a wire link with this LK2. I fitted a jumper so I can use it either way and not fit this connector at all. But as part of this demonstration, I'm assembling everything, so we've got all options on this particular CANMIO. So again, I'll just tack one of the 2 pins. That isn't very straight at the moment, as you can probably see. So now holding it up, my finger from behind, I'll just reflow that and jiggle it straight and make sure it's pushed fully home. It's looking a bit better. Looks okay. Just solder the other pin there. Reasonable amount of solder here. It's like a double pad to allow you to fit the bigger connector if you want to. Not that I've ever done so. Now we've got a couple of capacitors. These are reservoir capacitors for the input. There's one for the main 12 volts coming in and one for the I/O supply. And they are identical, so it doesn't matter which you fit where. As with the other bigger capacitors, they've got one leg longer than the other, which is positive. They've also got those dashes down one side, which is the negative. And if we look on the circuit board, 2 clues again. You've got the plus sign one side there, and although it's partly obliterated by the holes themselves, you can see the filled line there of the capacitor symbol is the negative side. So all of that means I'm going to put the positive this side. I'm going to do this one first because it's probably easier that way around. And just holding it with a finger, doing one of the pads. Then hold it firmly down, finger and thumb, whilst I solder that, reflow that. That should be sitting nice and square and fully down. This needs to be fully down onto the circuit board, not sitting proud if you're going to use daughter boards, otherwise it will foul them. And the second one of those going in now. We're not far away. Let's see, you can see what I'm doing. And solder one, hold it firmly, get it sitting down nicely. Visual check. And solder the second pin. There we go. And there's a little capacitor in there I forgot to put in. I should have put that in earlier because it would have been easier, but I can still do it. That's this 4.7 microfarad hiding in there, which is labelled on the board. Positive this end because I've got the plus sign and I've got the solid side of the capacitor that side. Likewise, longer leg goes to the positive. I can still get my finger down to that without having to mess around bending the legs. But here we go. Looking nice. So coming over the other side, I've got another 4.7 that easy enough to put that one in now. That's just there. So again, same rules apply. Because we've got potentially multiple power supplies on here, then there are a number of these capacitors to the supply decoupling. Do a little bit of gymnastics with my fingers to get them in the right place. Likewise the same. Wasn't there the same rules apply for this one? Thought it was stiff enough not to have to put my finger on. Of course, it's dropped back through, so a little less than there. So I'll just reflow that. Jeez, I haven't got enough solder on it to reflow it properly. There we go. It should do it now. There we go. Now it's popped up through. So that's just how I get out of the problem where I'd tacked it and it was going to be sitting high in the air. Another resistor pack. This is used for pull-ups on the output where required by the jumper. Likewise with this one, you've got the little, if you see it better on this one, you can see the dot on one end, and that needs to go where you've got the square pad and the little outline around that to show that that's pin 1 on the device. So again, I'm just going to pop that one in. That one's a little bit tricky to find because of the order in which I've done it, so I'm actually going to my fingers are too fat to get that in there, so I'm just going to use a pair of tweezers to drop it in. There we are. Now it's sitting there. I can comfortably just put some pressure on it with my finger. And tack the two ends. And solder up the other pins of that one. And then we've got 2 voltage regulators at the back here. Now, they are different. You do need to make sure you get the right one the right way around. VR1 here is labelled LM317. So that's what we're looking for written on the actual device. And on the board, you can see there's a line. That's the side the heatsink side goes. So it goes in this way around. The thinking being that if you were using this as an application where you were drawing enough current that these were going to get hot and need a heatsink, you can fit it on this side of the board, or you can put it in a case or a piece of U-shaped aluminium that bolts to the heatsink. Most applications, I very rarely put heatsinks on these. Most applications, they don't get that warm, and if they are getting hot, something's wrong, and you actually want the regulator to cut out rather than dissipating the heat away with a heatsink. These require a bit more heat with the soldering iron because they are bigger pins, and particularly the middle pin is not only connected to the ground plane on the board, but to the heatsink on the back, and all that's trying to whip the heat away from your iron. So once you're happy that's sitting quite nicely, I'll generally do the 2 side pins first. And then the middle one, I will have to hold the soldering on a bit longer till I get the solder to flow. There we go, we got it going now, and then hold it on a little longer to make sure it has flowed through the joint and made a connect. And then the other regulator, which is VR2, which is either a 5 volt or a 3.3, depending on how you're building the board. The standard would be 5 volt and would be a 7805, certainly with the standard kit. And we can see that that one is a 7805. The numbers 7805 are in the middle of all those numbers somewhere. So that's our correct regulator to go in that one. It's always worth checking both. I would advise against checking one and then assuming the other one's correct. Come unstuck there before then. So again, with a finger, tack one pin. Make sure that's sitting nice enough there. Background. And the same. Now, so the other two pins here as well. And again, the middle one, I believe I'm correct. It's not true of all devices, but I'm pretty sure the middle pin on this one is connected to the heatsink. There we go. So all that's left now is the connector at the end. Now I can't do that in my little holder because the two little pins are in the way. So I will have to take it out of the holder to do that one. And in fact, what I'll do, because I've got it out in my hand now, I'll take the opportunity to cut all those that little pin cushion off. And there we go. So now it's a visual inspection. See if any of the joints don't look great after they've been chopped off. And for example, here, so these two don't look so great. So I'm just going to resolder those. They're looking better now. But pretty much the rest I'm happy with. And then just to solder this connector now on the end. That'll drop on there quite nicely. Then a quick look underneath. Where are there still holes that I haven't put anything in case that's something I've missed? Well, one here in the middle of the crystal, because of course we're not using a resonator. That's okay. These two pins for if one chooses to use a little pin header for that connector instead of the connector. So those not being filled in is okay. That's for the little extra regulator if you're building it as 3.3 volts, so we don't need those. And these likewise are for if one's using a little pin header on the end or a Molex rather than the pins of that connector. So I don't see any other pins that we haven't filled in. That's always a good sign. And at this stage, I get my trusty toothbrush and a little bit of a cleaner. Wind well ventilated area required for this because it's smelly old stuff, not good for you. I'm just going to give it a quick, and that actually makes your soldering actually look better when you do that because it takes all the flux remnants away. And here we have one completed CANMIO without the chips in yet, and not looking too bad on the back with the soldering, having given it a clean off. So the next step will be to do the static voltage checks to make sure with power in nothing goes bang and that we've got the right voltages where the chips are going to go before we put the chips in.